If we look at the elements in the periodic table, this is how they would look like. Let's take an example of nitrogen, and this is how the box would look like. Now let's try to understand what does each of these represent. The first number which is written on the top is always a whole number. This number for any element is always a whole number. This is actually the atomic number of the element that is written underneath. Atomic number is also designated by the alphabet Z. Okay. This number gives us the information on the total number of protons present in that atom. And as we all know, the number of protons are always equal to the number of electrons in a neutral atom. This number gives us the identity of that element. This is the element symbol, which is usually written in capital letters. Now we are discussing the element nitrogen, and so its one letter symbol is capital N. However, we do have certain examples like calcium, which is designated capital C small a. Other one is iron, which is capital F and small e. So if the element symbol has two alphabets, then the first one is always in capital letters while the second one is in lowercase. Okay. So the third one is the full name of the element. This is the full name of the element. So we are looking at the element nitrogen now, and its atomic number is 7. Now this last one is called the average atomic mass. This is the average atomic mass, and it is usually not a whole number. This is usually not a whole number. And the reason for this is usually taken as the average of masses of all its naturally occurring isotopes. So each element will have a number of isotopes, which are nothing but elements that have difference in their mass numbers or difference in the number of neutrons in the nucleus. Okay, so this is the average atomic mass, and this is not the mass number of that element. Okay, so this is how the representation is on the periodic table, and this is what these numbers or the alphabets indicate in the periodic table. Moving on, in some cases you see something like this. Okay, now here again, this is the name of the element, which is abbreviated by its symbol. Now we know that this is nitrogen. This number here is the atomic number, which is designated by Z. So as we discussed earlier, so nitrogen has a total of 7 protons in its nucleus. So that's why this is equal to its atomic number. This is equal to its atomic number, which is 7. This value here is the mass number. This value here is the mass number, which is designated as capital A. Now mass number or capital A is the total number of protons and neutrons in the nucleus of that particular element. Okay, so because the mass number here is 14 and we know that it has 7 protons, so it will have a total of 7 neutrons. It will have a total of 7 neutrons. So this is what the top number designates. If you see a representation like this for any element, the bottom number is its atomic number, while the top number is the mass number of that element. Okay, and it's always important to remember that in a neutral atom, the total number of electrons is always equal to the total number of protons, and that is equal to its atomic number. Now let's look at two different isotopes of nitrogen. So this is what we discussed earlier. We also have another form of nitrogen which is designated like this. This lower number will always be the same because it is the atomic number, and that is what gives identity to that element. Here this has a different mass number compared to the other nitrogen. Now again, mass number is the total number of protons plus total number of neutrons. Okay, so mass number here is 15. We know it has 7 protons plus, so this particular nitrogen has a total of 8 neutrons, then only it can add up to 15. Okay, so nitrogen atom will always have the same number of protons, but it can differ in its total number of neutrons. Now these two are called isotopes. Because they only differ in their mass numbers, or they only differ in the number of neutrons, and it should be the same element. Okay, now how do we determine the total number of neutrons or electrons when we have it in the form of a problem? Let's say the ion of an element Y has 3 positive charges on it, which means this is a cation. Okay, so the element Y has negative charge on it, which means it is a cation in the first place. Okay, they've also given it has a total of 14 neutrons, and its mass number, which is designated by A, is 27. Now find out the number of protons and electrons present in the element Y. Okay, let's see how we can solve this. So let's understand the question first. So we have an element Y in its ionic form. Okay, the ion of an element Y has 3 positive charges, which means this is the element and it has 3 positive charges. So this is a cation to start with. And they are telling that this has, so let's put it here, Y 3 minus, has a total of 14 neutrons, and its mass number is 27. Okay, so mass number is always written as the superscript on to the left. So the mass number here, which is designated by A, is 27. Now they're asking us to find the total number of protons, which is always equal to the atomic number. So we have to find the total number of electrons and the protons and electrons present in this ion, which is Y3 plus. Okay, mass number, which is designated A, is equal to the total number of protons plus total number of neutrons. Now they've already given the mass number, which is 27. We need to find the number of protons. Let's designate it X, and the number of neutrons is 14. It's already given here in the problem. Okay, so 27 minus 14 gives you X, which is equal to 13. Okay, so 27 minus 14 gives rise to X, which is 13. So which means the atomic number of this element Y, is 13. So because the atomic number is 13, we can say that this element has a total of 13 protons. It has a total of 13 protons. Okay, so now Z is 13. However, we can see If Y was a neutral atom, it will have 13 protons and 13 electrons if it was a neutral atom. But the question is already telling us that it is an ionic form with 3 positive charges. 3 positive charges, meaning it has lost 3 of its electrons. So this will have 13 protons but only 10 electrons, because this is the ionic form of that element and it has lost 3 electrons. So the answer for this would be the total number of protons is 13 and the total number of electrons is only 10. So once you know the total number of neutrons or the total number of protons, you can accordingly calculate the mass number of that element. Okay.